Hello, I'd like to introduce our newest ICCAP release, ICCAP 2009 Update 1. We will start by covering how our new integrated solution for measurement and modeling of high voltage, high power devices can help you to measure and extract more accurate models. Then we'll talk about the new upgrades and features included with our turnkey CMOS extraction packages, such as ISM-HV, VSM4, and PSP. Finally, we'll take a brief look at the announcements in the simulation and programming areas. For each one of these features, I will show you live demos. Before we continue, I'd like to mention that with Update 1, we add support for Windows Vista and Linux Red Hat 5, in addition to the already supported Windows XP and Linux Red Hat 4. We continue to provide support for Solaris 10 operating system. High voltage devices often need to be characterized up to several hundreds of volts, sometimes even thousands, like in the case of DMOS devices used for hybrid cars electronics in the automotive industry. RF power devices such as LDMOS can withstand several tens of watts and must be measured under pulse conditions to avoid thermal runaway and device self-destruction. As an example, measured data from a power LDMOS used in RF applications are shown below. Notice that the maximum dissipated power during the measurement is as high as 30 watts. Another challenge is the lack of standard models for compound semiconductors device. In general, the high power nature of these devices makes their measurement and modeling very challenging. Thanks to the added measurement driver for one of the newest Agilent instruments, the B1505A Power Device Analyzer, and the upgrade of the ISM-HV CMOS extraction package, ICCAP now provides a complete measurement and modeling solution for high voltage CMOS and RF LDMOS devices. The new ICCAP driver supports all the different modules of the B1505A in both DC and pulse modes for high power, high current, high voltage, and capacitance measurements. Let's now take a closer look to the powerful ISM-HV extraction package. This window shows the default flow for extracting the ISM-HV model of power LDMOS devices. Each extraction package comes with a robust and smart extraction sequence developed by our experts. The flow includes several extraction steps. Each step executes several extraction functions from a predefined library. The list on the right shows the available function library for this step. Let's consider the step extracting the BTH and mobility parameters from measured data of the large device. The default extraction includes 5 library functions, 1 direct extraction, 3 optimizers, and a final tuning step. Other library functions are variable on the right and can be added to the flow on the left to customize it. To extract the full model, a user will start from the top and proceed step by step to the bottom. The entire flow can also be executed automatically by selecting the flow and choosing the Execute menu option. Later on in this video, we will see how ICCAP 2009 Update 1 lets the user create custom library functions and add them to the existing flow. VSM4 and PSP extraction packages have also been updated to support the latest versions of these popular industry standard models. The user interface of all CMOS extraction packages was completely redesigned in ICCAP 2009 using a new UI platform technology. We recognize that no semiconductor processes are created equal, and we understand the importance for engineers to customize the extraction and use their own expertise to make the flow more robust. With Update 1, we've gone one step further in providing the ultimate customization by enabling any user to easily create custom library extraction steps that can be used in the main flow. Let's watch a brief demo of this feature and use the PSP extraction package as an example. In the PSP extraction window, let's select the Extraction tab. As we know, the main flow is shown on the left side. Let's consider the extraction of the BTH and mobility parameters from the large device. An extensive set of library functions is available on the right side. However, let's assume I want to create a new optimization or tuning step that only uses the parameter U0. The first step is to invoke the configuration wizard. A new window will be displayed. In the wizard window, let's go to the first tab which shows all the available extractions for the PSP model. Let's find our BTH mobility extraction step in the global group. For now, only built-in extractions are present. Built-in extractions cannot be edited. To add a custom extraction, I select a built-in and make a copy. Now the copy can be edited on the right side. The function can be of type extraction or optimizer tuning. I will select optimizer for the sake of time because extraction would require writing some PL to actually extract the parameters. I can change the name to U0 and delete the other parameters from the list. I leave the large device as selected data source and I'll confirm the two plots already selected. At this point, the new function has been created and I can exit the wizard window and return to the PSP extraction flow. Let's now go back to the main PSP extraction flow and open the BTH mobility extraction step again. On the right, notice that there are two new functions available, the U0 optimizer and tuning. The new step can now be inserted into the main flow and can be used to customize the flow. To summarize, this new tool provides the ultimate flexibility to easily create custom extraction steps through a very simple user interface. In the simulation links area, Update 1 now supports HSpice compatibility mode simulation in ADS. This mode enables simulation of ICCAP circuits defined with HSpice syntax to be simulated directly in ADS. This is extremely convenient for users who prefer to use HSpice native syntax but still want to take advantage of the most efficient and convenient ICCAP ADS link. To use this feature, set your simulator variable to HSpice mode ADS. As a reminder, ADS basic linear and transient simulation licenses are included in the base ICCAP analysis license at no additional cost. In the programming area, new PL functions such as whoami and whois have been added to make programming more efficient. The function whoami returns the full path of the current macro or transform. The function whois returns the name or a type of an object. A new feature allows user to add programmable buttons in the status window to interact with ICCAP, even when PL programs are running. I'd like to show you how with little programming effort, this new feature can be used to make your PL programming more efficient, safe, and robust. Let's load one of the two examples provided in the miscellaneous directory, the statusbutton.mdl. When I double-click on the model icon, a PL program displays a simple dialog. When I start the demo, PL creates 3 buttons on the status window and then goes on to execute a simple loop that just updates the current iteration counter. This loop represents any algorithm, such as a complex automated measurement routine. At this point, with ICCAP 2009, a user who wanted to regain control would need to either wait for the PL to finish or use the ICCAP main stop button, which abruptly stops any PL activities, leaving the program in an unknown state. With ICCAP 2009 Update 1, user can now press one of the user-defined stop or pause buttons in the status window toolbar to influence PL execution and gracefully pause or stop running PL. Obviously, the PL program needs to be designed so that it periodically checks for the status button queue. For more information about ICCAP 2009 Update 1, please refer to the following 2 web pages. In the first web page, you will find a link to the Update 1 download page. This update does not require new licenses, so if you are an existing customer, you just need to download and install the new version, and you will be up and running within minutes. If you are a new customer and wish to check out ICCAP 2009 Update 1, please request an ICCAP evaluation license by clicking on the dedicated link in the download page. Thank you for watching.